Now that we've gotten a little bit of experience into the inverse functions or the arc functions, we learned how to graph them. So of course we want to kind of take those functions and try to see if we can do it in equation form. And what I'm going to point out here more than anything is a little trait that we get with those inverse functions that really helps us out when we're in equations. If I gave you any number, let's say 3, and I told you to multiply it by its inverse, aka its reciprocal, so anything times its inverse, remember we always get 1. It's kind of like sine of x times its inverse, which is cosecant of x, we always get 1. Okay? Well, what we're really focusing on is specifically the inverse function of sine. So if I take sine and I multiply it by arcsine, which is the same thing as if I said sine times sine inverse of theta, it's sine and sine inverse go away, and what you get is just your angle left over. Same thing with cosine. Cosine times its inverse, and we just get at the angle that's sitting right inside there. Tangent times its inverse, and we get that angle sitting right inside that parentheses. Okay. What steps 3 and 4 are telling you right here is what do you do if you've got an opposite pairing, like sine and cosine inverse, or cosine and sine inverse. And then again, it still deals with that angle that's sitting in there. It's just going to be the square root of 1 minus that angle squared. Okay, so let's go off into our first example. We want to evaluate cosine arc cosine of negative 2/7. Well, cosine, I have arc cosine, they match up. So cosine of arc cosine, nothing fancy here. So those two almost cancel each other out, and my answer is just my angle, which happens to be negative 2/7. Okay, with sine arc cosine of 1/5. Okay, because those two don't match up, I don't have sine and arc sine, I have sine and arc cosine, then what I need to do is use the other rule. It says it's the square root of 1 minus that angle, which is 1/5 squared. So it's the square root of 1 minus 1 over 25, and then from here just cleaning it up. So 25 over 25 minus 1 over 25 is 24 over 25. And let's keep cleaning this up. We can write 24 as, let's see, 6 times 4 probably. So the square root of 4 is 2. Square root of 6 we leave in there. And the square root of 25 is 5. And so there's the answer for the second one, and there's the easy answer for the first one. Alright, example 2. How example 2 differs from what we just did a second ago is the fact that now in our angle we actually have a variable. Up above, the angles were just had like 2/7 and 1/5. There was no variable in there. Now that we have a variable in there, we have to do this one extra thing when we give our answer. And that's what this whole part right here on example 2 is telling us about. Okay, so cosecant arcsine. Well, we don't have anything for cosecant, but I know that cosecant is 1 over the sine of any angle. And what my angle is everything in this bracket. So arcsine of x over 4. Okay, so cosecant of all of this is same thing as 1 over sine of all of this. So the only thing that changes is cosecant goes to 1 over sine. And that kind of helps us out because now sine and arcsine match up. We get 1 over x over 4, which is the same thing as saying 1 times the reciprocal of that bottom, so 4 over x, and we get 4 over x. Okay, now because we're dealing with, I'm going to box that up, and that's only half of our answer. Because now that we're dealing with a variable, we got to have the other half of our answer. And this is the part where we come in where that, if you looked at above, it said we have to really pay attention to our domains for our inverse functions. That's where this part's going to come in. Coming right back to this part, do you notice that whenever I have the sine arcsine, I have this little stipulation that says my angle that's inside here can only be between negative 1 and 1. Because what that says is the range for our original functions, so the original cosine, the original sine, remember it was a curve, a wave that went from 1 to negative 1, 1 to negative 1, forever and eternity. Well, that range there is now our domain for these inverse functions. Okay, so the same thing with there. And that's what we're going to use down below on example 2, so let's go back there. Okay, so it's saying that I can only use those rules, the rules that I've done to basically solve this out and simplify this out, as long as my angle, which is x over 4, is something that's between -1 and 1. Okay, well, I just want to get x in the middle, typical interval notation. So what I'm going to do is multiply basically all three parts here by 4. So this is the same thing as saying -4 is less than or equal to x, which is less than or equal to 4. Okay, so we're almost there, finishing up. What we have just found is the fact that cosecant arcsine x over 4 will equal 4 over x as long as my x value is anything between -4 and 4. And hopefully y'all are looking at this and realizing, hey, there's one more value that really is in this interval that I have to exclude. Just remember, we can never divide by 0, so x cannot equal 0. Okay, so when you give your answers to this, your answers technically are what you simplify out to, that first box, and it's this. You have to list your restrictions. So let's go back to the directions. It says we want to simplify the following expressions. Well, I've done that. The following expression simplified is 4 over x. And then we want to be sure to state any restrictions that the angle may have. Well, here are your restrictions. It can only be between -4 and 4, and x cannot equal 0. So there's the two parts of that problem. All right, let's go to part B. Cotangent arcsine. I don't have cotangent, but I know that cotangent is cosine of our angle divided by sine of our angle. Okay, so let's fit in our angle and arcsine again. So it's like an angle within an angle. That's okay. And now we're just kind of cleaning this up. Up here at the top, we have the mismatch. So we're going to do 1 minus my angle squared over, and down here we match up, so we just get x over 3. Okay, so cleaning up some more. Square root of 1 minus x squared over 9 divided by x over 3. So 9 minus x squared over 9 over x minus 3. So splitting up the square root here, we have the square root of 9 minus x squared. The square root of 9 there is 3, divided by x over 3. Okay, let's keep working here, some algebra. So we're almost done cleaning this up. I'm going to take the top fraction, and I'm going to multiply by the reciprocal of the bottom fraction. Cancel, cancel. So we get, really, after all is said and done, the fully simplified version is this right here. Okay? And, like I said, that's part 1. Part 2 is defining on when this can actually work out. Well, arcsine, and I know arcsine says that that angle can only work between -1 and 1, which means that same thing as saying x then is between -3 and 3. Also another stipulation, because I have x here in the denominator, I know that x cannot equal 0. So there's part 2 of my answer. Okay, and I kind of want to take 2 seconds and check, because I am dealing with a radical on the top now, and I want to make sure that every number inside this interval I can actually take a square root of. So let's say 3. If I plug in positive 3, so 9 minus 3 squared, 9 minus 9 is 0, and looks like I have to take a square root of 0, and I can take a square root of 0. It works. The only thing I can't take a square root of are negative numbers. So that checks off, and we can go to the next problem. All right, here with the example C, we have a little unique thing. So we're taking the sine, and we're used to seeing, we're not used to seeing this part right here. We just see sine, arc, cosine. But now what's inside this bracket is a sum of two things. And guess what, guys? We're going to be pulling some information from back in the past. Some fun stuff. Is the fact that anytime I'm taking the sine and my angle, like, do you remember this formula? The sine of where my angle in here is the sum of two things. Yeah, we have a new form. We have that formula that says if I want to break it up, it's the sine of the first, cosine of the second. We use the same sign. Cosine of the first, sine of the second, and that's what we're using here. So let's take that and clean this up. So it's the sine of the first times cosine of the second, and the second is all of that right there. So arc cosine of x over 3. And then plus, now cosine of the first times sine of the second. And sine of arc cosine x over 3. Okay, so let's clean this up. The sine of pi over 2 is 1. Cosine, arc cosine go away, so it's 1 times x over 3 plus cosine of pi over 2 is 0, the x value there, and sine, arc, cosine, they don't match up, so we would normally do the square root of 1 minus x over 3 squared, but because we're going to be multiplying this thing by 0, technically all that term goes away. So all of that cleans up to is x over 3. Okay, so there's the simplification process. Now I'm going to go up there to my inverse portion, go to the angle, and arc cosine, I need to put that between the angle of x over 3 between -1 and 1. Because anytime I have arc cosine or arc sine, I always take my angle and put it between -1 and 1. And multiplying everything through by 3, so I just get x in the middle. Okay, so coming back over to my simplification process, I don't have any variable in the denominator anymore, so I don't have to worry about dividing by 0. The top doesn't have any radicals or anything, so we can box that up and call it done. We don't have to worry about excluding anything more. So that checks off, and we are good to go to the next problem.